Go. Okay, lecture on Chapter 5. We're going to do this in two parts. Today I hope to get us in a position where you understand the tables and the bending portion of it. That's going to get us through 5.4. And then we've got a shear, bearing, deflection, rafters and joists left. That'll be the second part, okay? This is really important right here. If you can't get the right data, no matter how good you do as far as calculating, you've got the wrong answer. So I need you to turn. I put them up here on the board, okay? I need you to turn to page 194 and 195. We're going to edit this thing. I'm going to have you play around. Hopefully you've got a pencil or a highlighter or whatever you use to get things in the right order with you. So we're going to edit this thing, and when we get done, hopefully it'll make sense. You have something to go to that you can understand. Okay, I didn't put it all there. You've got it. You got species here and grades. You've got Doug for Larch, and you've got select structural number 1, and then you go down underneath timbers. You got dent, select structural, and so on. So these are all filled in, okay, on yours. So you got a bunch of things in each of these. That's the grade. So the problem's going to tell you the grade. The grade is how good it is. Like Hamburg steak, Joyce Prime. This is the same type of thing. Okay, now this is the important part. Now I'm going to get rid of the crap we don't need. First of all, put an X through that. Decking's gone. Okay? I'm going to do that in red, then I'll do the blue in the field. Okay, the decking is gone. Get rid of it. So the bottom part of that table, you don't need, the very bottom. Anything underneath the number 2 in posts and timbers, number 2 in posts and timbers, anything below that, you don't need. Okay. We've got letters, and you know some of them, and I'm going to put them on the board now for each of these vertical columns. Bending, hopefully you remember, FB. Tension parallel to grain, FT. Tension or shear stress, allowable, FV. Shear diagram, V. Compression perpendicular, FC perpendicular. Next one is FC parallel, and we just use FC for that one. And then modulus elasticity and the minimal modulus of elasticity. Okay, so out of that, you're going to now get rid of this column somehow. We're not using that one. That one's gone. The bottom of the table's gone. Okay? So now we're down to something a little bit more manageable, not real, but a little bit. Oh, well, how do we use this baby? Well, let me tell you the important part. You got 3 cells here. Okay? 3 cells. I'm going to call this from here up cell 1. From here up, cell 2. And the last one is cell 3. Okay, now cell 1 is for any member, any member, whether it's a post, a beam, a column, a rafter, any member you got that has a minimal dimension between 2 and 4. Okay? Dimension 2 to 4. So in this case, any member that has a minimal dimension of 2 to 4. So a 2 by 8, a 3 by 12, a 4 by 16. Those are all qualify for that. A 6 by 10 doesn't. Okay? So if it has a minimal dimension of 2 to 4, you're going to always go to the cell 1. Okay, that leaves us everything greater than or equal to 5. Okay? So timbers are anything greater than or equal to 5. So cell 2, greater or equal to 5, and cell 3, if its minimal dimension is greater than or equal to 5. Okay, the difference between cell 2 and cell 3. Cell 2 is for beams. Okay, so if your member is a beam, is fatter than 5 inches, you go to cell 2. If it's a post in timber, if you want to put something in there that makes sense to you, this is chapter 5, this is chapter 6. Okay? So, chapter 5 and chapter 6. So if it's in either chapter, 5 or 6, it's between 2 to 4 minimal dimension, you're going to use cell 1. If it's in chapter 5 and it's a beam that's fatter, 5 inches or fatter, you're going to use cell 2. If it's in chapter 6, it's a post or a column, and it's fatter than 5 inches, it's going to be in cell 3. Okay, so that'll get you into the right cell. Okay, now you got to make sure you understand what you're solving for. Are you solving for bending? Are you worrying about shear? Are you worrying about something sitting on there and bearing and squashing? Are you worrying about deflection? So I'm going to go ahead and write in these guys, those columns that are left, where you're going to use these values. Okay, the first one is bending. Of course, bending, beam. So in chapter 5.4, let me get something that writes a little better. In chapter 5.4, you're going to be using that one. So I'm going to write them right here. They don't go here, but I'm going to write them right here. So this is going to be yours in chapter 5.4. Bending, FB. Okay, next one. If you go to 5.5 in your text, it's going to be shear. So that's going to be here. Okay? So I'm going to turn, and you might want to too. We've got to 5.4. 5.5 is shear. We move into the next one, and if I look at it, it says bearing. Okay? Bearing. And if you start going through this thing, you start looking at it fairly closely, you're going to find out that it is compression perpendicular to the grain. That's this one. Okay, and then the last one we're going to do in this chapter is deflection. Deflection is this guy right here. So there's where you're going to use those. Okay, we haven't got ourselves in a position where we've used them all, but we're still not done. Okay? So there's chapter 5, pretty much whipped. Okay, we're going to go into chapter 6 now. Chapter 6. If you look in chapter 6 at all, I know you haven't yet, and you're not supposed to have, but if you start looking at it a little closely, you're going to find out there's some equations there, and those equations have data you need, and I'm going to go to chapter 6.2. And if you start looking around in chapter 6.2, you're going to find out you need a couple of things. And 6.2, you're going to need this. And you're going to need this. They're columns. Compression. We compress them and bend them. Okay? So that'll get you out of that one. And I think that's all you need in that particular one. And then if we go on and we go into the next part of that chapter we'll be covering, which is 6.5. 6.5 has this. has this, and it has this. So you see, we use them all, and we never touched that F sub t that I got rid of. So there's where you're going to use them, okay? So it depends on the thickness. If you're in chapter 6, of course, you're going to be down here. This will be 5 and 6. This will be 5, and this will be 6. Okay, 5 and 6. 2 to 4, both. 5 inches or bigger, and it's a beam, you use cell 2. 5 inches and bigger, and it's a post, you use cell 3. So that'll get you numbers, and all you got to do is go in with the grade, move yourself across underneath the proper column and grab the number, and that's it. So you should be all set there. So that should take care of the big table. This is one you're going to be using. I don't know how you're going to get back and forth to it, but it's going to be very important for this unit. It does everything. So hopefully you got it. Okay, now this particular table is meant for various sizes of woods, but as woods get bigger and change dimensional shape, there's more probability of having knots, small cracks and things in larger members than there is smaller. So we have a couple factors that we need to apply. The factors are in table 5.2, which is this one, and 5.8, which is that one. Okay? So I want to explain those two tables for you. Once we have those, we're okay. Okay, once again, get rid of this. That's gone. And then, underneath the line that said stud, now you should be on page 197 if you're with me. So I'm going to go back to page 197 so I'm with me. Okay? And underneath it says stud, okay? See where it says stud on the table? Hopefully you can see that. If you look at where it says stud, it's got some numbers underneath there. I want you to draw a line just above stud. Draw a line just above stud. And get rid of everything below it. Everything. Everything below it's gone. So now you got a table that's a little bit smaller, a little bit easier to use. We're not going to use, that really isn't what you think it is. That isn't a stud. It's a stud grade. Okay, we're not going to use that. We're not going to do walls or studs. So now you're down to a big column with 2 sub-columns and a little column. Okay, where are you going to use these? You're going to use this in chapter 5. FB, bending, chapter 5. Okay, we won't need it in chapter 6, so don't worry about it. This you're going to use in chapter 6. Now, what is this table for? Look at it. 2, 3, and 4 inches. So this is going to be for lumber that is 2 to 4 inches thick. Thick, in their words, what they're thinking is the minimum width, okay? So thickness is the littlest number. If you measure 2 sides, thickness is the smallest of the 2. Okay, now I got about 2 more things to explain, and we'll be done with this one, and then we can move on to chapter 5, the 5.8, which is a real quickie, and we'll do a couple problems. Okay, you got 2 lines here of data. You got 1 line of data here. Okay, now this over here, grades. Draw a circle around it. It does not relate to a line. This is not related to that line. This is not related to that one, and this not to that. This is a bundle, and it relates to all of them. So don't go thinking that select structural is only associated with this. It's one group. Basically, it says it's all species, okay? And grades. So that's a bundle. It's not a line item. So now you got that. Now all I got to do is worry about if the thicknesses are 2, 3, or 4. So if you're 2 or 3 inches, smallest dimension, you're in that column. If it's 4 inches, you're in that column. Now, this is the other dimension. This is the fat dimension. So if I had a 2 by 8, I would go 2 down to 8, and that's where I'd land. A 3 by 10, 2 to 3, I'd be in this column. I'd go down to 10. That's where I would land. If I got a 4 by 12, 4, go down to the 12. That's where I'd land. So all you got to do is figure out how wide it is. Now, if it's only 2 to 4, what does that mean about these two? You don't use this table for anything 5 or bigger. 5 inches or greater, no table. So any of the values you get in the chart that are from this line down will never have a factor associated with table 5.2. Only the numbers you get out of this table that are from here up. So this is only good for lumber that's 2 to 4 inches thick. So go across, and what you're doing with this number is you're addending the magnitude of the allowable stress based on its size. They already know how many imperfections it can have and so on, and they adjust the allowable stress based on the physical size of the member. So that takes care of that one. Okay? Now the last one's real easy. If you go to page 206, you're going to have a table. It's in the upper left-hand corner. And if you do that, you're going to end up, I'm going to put this right here. I think I'll add this, and maybe you want to too. It makes sense to me now that I think about it. So you're going to use table 5.2 in those two areas, okay? Notice I'm going to do this so you don't get all confused. Okay? You use those in that area on 2 to 4 only.